Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on finding the median and quartiles from group data, so linear interpolation. And this is quite useful for questions perhaps whenever you're dealing with histograms and finding the median from a histogram, because you can go back to the frequency table and then you can work out the estimate for the median or the lower quartile, upper quartile, and so on. And if you need any extra help on this topic, if you go to the videos and worksheets section on Corbettmaths and scroll down to video number 52, there's a dedicated video tutorial there on linear interpolation. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says 100 students at a physics examination. So this is this physics exam, and there's 100 students altogether. And the time that they spent revising is shown in the table. So 27 students spent more than 0 hours, but less than or equal to 5 hours. So here it looks like everyone studied for the exam. No one spent no hours revising. So these 27 students spent more than 0 hours, but less than or equal to 5 hours. 44 spent between 5 hours and 10 hours, so bigger than 5 hours, but less than or equal to 10 hours, and so on. And the question says, by using linear interpolation, find an estimate for the median time spent revising. So we're calculating an estimate for the median. So we want to find an estimate for the median. So what we're going to do is we're going to find the position of the median to begin with. Now, because this is group data, what I'm going to do is I'm going to use n over 2. So rather than using n plus 1 over 2, and as we would for a list of numbers or a non-grouped frequency table, because this is a group frequency table, I'm going to use n over 2. Because it's an estimate anyway, we're just going to use n over 2. So I'm going to take the total frequency, which is 100, so I'm going to take 100, and I'm going to divide that by 2, so I'm going to be looking for the 50th value, so the 50th value. Now, some teachers and websites may use n plus 1 over 2, but I tend to use n over 2, and whenever you look at the mark schemes for these questions, quite often the n over 2 is the first answer is written down by the exam board for the question, but they'll also say except n plus 1 over 2, but I tend to use n over 2. So we're looking for the 50th value. So to find our estimate for the median, we're going to find the 50th value. So is the 50th value in here? No, that's the first 27 students. Is the 50th value in here? It would be, because if we've gone 27 and then we go in over 44, then it'd be equal to 71. We've gone past 50. And actually, so that means the median value is in here. And then what we're going to do is we're going to use the formula for linear interpolation. And the formula for linear interpolation is the lower bound. So the lower bound plus the number into category. So the number into category over the number in category times the class width. So if we want to find an estimate for our median, what we'll do is we'll look at this group here, this class interval. We'll find the lower bound, which is 5. Then what we'll do is we'll find the fraction into the group we want to go. So because we've gone 27 and we're looking for the 50th value, we need to go number 23 into the category out of the 44 in the category. So that's going to be our fraction times the class width, which is 5. So let's just use that formula. So we're looking for the 50th value, and just remember this is an estimate anyway because we don't know the actual values. So in terms of this category, the lower bound will be 5 plus the number into the category. So we're looking for the 50th value. We've gone 27 so far. We need to go another 23. So we need to go another 23 into the category over the number in the category, so 44. So we're going 23 44ths of our way through this category times the class width, and that's how wide the class is. So in terms of how wide this class is, we just take this value away from this value. So 10 take away 5 is 5. This category, this class interval is 5 wide. So multiply by 5. And now we just need to work this out. So we can get our calculator and we can just type in 5 plus, and then type out our fraction, 23 over 44 multiply by 5. And when we do that, we get an answer of 7.6136 and so on. And let's just round that. Let's round that to 2 decimal places. So that'll be 7.61 hours to 2 decimal places. And that's our estimate for the median using linear interpolation. And that's it. Okay, let's look at our next question, question number 2. Okay, so question number 2. Question number 2 says 50 people work for a company. So we've got 50 employees for this company, and the table shows information about their monthly salaries in pounds. So we've got their monthly salaries here, and we've got the frequency. So 21 members of staff have a salary that's bigger than or equal to £1,600, but less than £2,400 a month, and so on. And the question says find an estimate for the median monthly salary. So again, it's an estimate because it's group frequency data. We don't actually know the actual values. We don't know the actual salaries, but what we're going to do is we're going to find an estimate. So to find our estimate, we're going going to find out how many people there are all together. So the question says there's 50, and if you were to add up the frequencies, you'd find there's 50. So we're going to use n over 2 to find the position of the median. So we're going to do 50 divided by 2. And 50 divided by 2, 50 divided by 2 is equal to 25. So we're looking for the 25th value. So we're looking for the 25th value, and we're going to find out what that value is, and then that will be our estimate for the median. Okay, so is the 25th value in here? No. Would the 25th value be in here? Well, yes, if we had 21, we just need to go over 4. This category has got a frequency of 12. So yes, the median would be in there. So that means we're going to look at this category here, and we're going to use our formula, our linear interpolation formula. So that's the lower bound plus the number into category, or class interval, over the number in the category or the class interval, times the class width. So in terms of this category here, the lower bound, well, it's going to be 2,400, so 2,400 plus the number into the category. So we're looking for the 25th value. We've had 21 so far, so we need to go 4 into this category. So we're going to go 4 into the category, over, and in that category there's 12, so it's going to be 4/12 of the way through that group, and then times the class width. And in terms of this category, if we do 3,200, take away 2,400, that's the class width, how wide that class is, and that's equal to 800. So we're going to multiply by 800. And now we can just work this out in our calculator. We can do 2,400 plus 4/12 multiplied by 800. And then we can just type that into our calculator and work it out. If this was a non-calculator paper, what I would do is I'd simplify this fraction to be a third. I would work out a third of 800 using division. And then what I would then do is I would then add that onto 2,400, and that will be our estimate for the median salary. So let's work this out. So it's a calculator question. So 2,400 plus 4/12, which is a third, multiplied by the class width, which is 800, gives us an answer of 2,666.66 and so on. And I'm going to round that to the nearest penny, so that's going to be £2,666.67. And that's it. That's our estimate for the median salary. And that's it. Now also, if you did this question by using n plus 1 over 2, that would be accepted. So if you're looking for the 25th value, instead of being 4 into this category, it'd be 4.5 into that category. So you do 4.5 over 12 times 800, and the answer would just be slightly higher. But I said that would be accepted, but this is the approach that I would typically use whenever you're dealing with group frequency tables. Okay, let's look at our next question, question number 3. Okay, so question number 3 says, Alison measures the heights of her plants in her greenhouse. So she's measuring the heights of all the plants in her greenhouse. And part A says, find an estimate of the median height. So we want to find an estimate of the median. So let's work out how many plants are all together. So let's add up the frequencies. So 3 plus 7 plus 12 plus 31 plus 27 is equal to 80. So she's got 80 plants in her greenhouse. And we want to find an estimate of the median. So let's find the position of the median. So because it's an estimate, we're going to do n over 2. So it's going to be 80 divided by 2, which is equal to the 40th value. So we're going to look for the 40th value. So is the 40th value in here? No. Another 7, that's 10 so far. Is it in there? No. Another 12, that's 22. So would the 40th value be in there? No. Now we've got 22, we now go another 31, that'll be equal to 53. So is the median in here? Yes it is. So that's the group that the median would be in, that's the class interval the median would be in. And now we just need to use our linear interpolation formula. So that's the lower bound plus the number into the category over the number in category times the class width. Okay, so in terms of this class interval, the lower bound would be 30. Plus the number into the category. So we've got to 22, 3 plus 7 plus 12 is 22. We need to find the 40th one, so we need to go another 18. So it's going to be 18 into that category, over the number in the category, which is 31, times the class width. And the class is 10 wide, so times 10. So we're just going to type this into our calculator. We're going to do 30 plus, and then our fraction button, 18 over 31 times by 10, and that would be equal to 35.806 and so on. And I'm just going to round that. I'm going to round it to 3 decimal places. So that'll be 35.806 centimeters to 3 decimal places. And that's it. Okay, now part B. So part B says find an estimate for the lower quartile. So we want to find our estimate for the lower quartile. So remember, lower quartile is a quarter of the way through the data. So if we have a look here, we had 80 plants all together. And I'm actually just going to change the color of pen here. I'm going to go to blue. Okay, so we're finding the lower quartile, our estimate for the lower quartile. There's 80 plants all together. So if we do 80 divided by 4, and that would be equal to 20. So we're looking for the 20th value. So for the lower quartile, we're going to be looking for the 20th value. So let's find where the 20th value value would be. So is the 20th value in here? No, there's just 3 there. And another 7, that's 10. So is the 20th value in there? No. Then we've got another 12, that'll be 22. So is the 20th one in there? It would be. So the lower quartile is in this class interval here. Okay, so let's go down here. And we're going to use the same formula. So the lower bound plus the number into the category. So number into category over the number in category times the class width. Okay, so the lower bound, so let's go up here. The lower bound here would be, for this category, would be 20. The lower bound is 20, so 20 plus the number into the category. So if we have a look here, we're looking for the 20th value. We've gone 3 and 7, so we've gone 10 so far. So the up to the end of this category is 10. We need to go to find the 20th one, so we need to go number 10. So we're going to go 10 into this category, and there's 12 altogether. So we need to go 10 into the category, and the number in the category is 12. And we're going to times that by the class width. So if we have a look at this class, it's 10 wide. That's how wide it is. It's 10 wide. So we're going to multiply by 10. And then if we just work this out, this will give us our estimate for the lower quartile. So we're going to do 20 plus 10 twelfths multiplied by 10. And that gives us an answer of 28.333 and so on. And let's just round this to 3 decimal places as well. So that's going to be 28.333 to 3 decimal places, to 3 dp. And that's it. That's our estimate for the lower quartile. So the only thing that's different in terms of finding an estimate of the lower quartile than the median is just finding the position. So rather than using n over 2, we're going to use n over 4. And that's it. Okay, part C. Part C says find an estimate for the upper quartile. Okay, so I'm going to change colour of pen again, and I've changed colour to green. And we want to find our estimate for the upper quartile. So in terms of the upper quartile, halfway through the data would be the median. Quarter of the way through the data would be the lower quartile. The upper quartile is 3/4 of the way through the data. So we need to do 3/4 of 80, and 3/4 of 80 would be 60. So we're looking for the 60th value. So we're looking for the 60th value. So is the 60th value in here? No. No, no. So this was 22 up to the end of this category. Then another 31 would be 53. So is the 60th value in here? No. So the 60th value, the upper quartile, would be in this last class interval here. So we're looking at this class interval here. So let's go down, and we're going to be using the interpolation formula again. So it's going to be lower bound plus the number into the category, so into category, over the number in category, so the fraction of the way through that class interval, times the class width. Okay, so the lower bound, so for this last class interval, the lower bound is 40, so it's going to be 40, so 40, plus the number into category, so the fraction of the way through the group. So let's have a look at this, the number into category. So we've got to 53, we want to get to the 60th one, so we need to go another 7. So it's going to be 7 into that category over the 27 in that category. So it's going to be 7 27ths into that category. So 7 into the category over 27 in the category times the class width. And if we go up here, the class width here is 10. Again, it's 10 wide. 50 take away 40 is 10, so that's 10 wide. So then take away times by 10. And then we just need to work this out. So we can just type this into our calculator. 40 plus, and then our fraction button, 7 27ths multiplied by 10. And when we work that out, we get an answer of 42.59259 and so on. And again, let's just round this to 3 decimal places. There's going to be 42.59, and then we've got 25, so we're going to round up 3 to 3 decimal places. Okay, then part D, our last part. Our last part says find an estimate for the interquartile range. So remember, the interquartile range, the IQR, is the upper quartile subtract the lower quartile. So our upper quartile will be 42.5925 and so on. I'm using the unrounded version here just because I want to increase my accuracy. Take away the lower quartile, which was 28.333 and so on. And when we do the upper quartile, take away the lower quartile, or our estimate of the upper quartile, take away our estimate of the lower quartile, that'll give us our estimate of the interquartile range. So whenever we take away 28.33333 and so on, we get an answer of 14.259259 and so on. And let's just round this. Let's round it to 3 decimal places again. So that'll be 14.259 to 3 decimal places. And that's it. That's our estimate for the interquartile range. Okay, let's have a look at our next question. Question number 4. Okay, so question number 4 says, the weights of some rugby players are recorded in the table below. So we've got the weights of some rugby players and we've got the frequencies and their weights. And part A says, calculate an estimate for the mean weight. So we want to find an estimate of the mean weight. So not an estimate for the median, that's going to be part B, an estimate of the mean in part A. So we want to find an estimate of the mean. So remember, an estimate of the mean, we do the midpoints times the frequencies to find the FX column. I'm just going to put that on the FX column. So we're going to do the midpoint times the frequency, midpoint times the frequency, midpoint times the frequency, and so on. Because obviously if you get 10 values between 60 and 64, it would make sense to consider 62 and do 10 times 62, and that would be 620. And that would be our estimate for the total mass of those players, or total weight of those 10 rugby players, and so on. So we add on our FX column. So we're going to do the midpoint times the frequency, midpoint times the frequency, midpoint times the frequency, and so on. So we're going to do 66 times 20. We're going to do 70 times 30. We're going to do 74 times 15. We're going to do 78 times 18. And we're going to do 82 times 7. So let's do that now. So we've filled out our FX column. So that's our estimates for the total of each one of the categories. Now we're going to add those up to find our estimate for the grand total. So we're going to do 620 plus 1,320 plus 2,100 plus 1,110 plus 1,404 plus 574. And it's very important you're very careful whenever you're typing those into your calculator. And I've got that's equal to 7,128. Okay, so we've now found the total of the FX column, so our estimate for the grand total, the estimate for the total weight of the players. We now need to divide that by the total frequency, or the number of players. So we're going to add up our frequency column. So 10 plus 20 plus 30 plus 15 plus 18 plus 7, and that's equal to 100. So there's 100 rugby players. So there's 100 players. So if we take our 7,128 and we divide that by 100, that's going to tell us our estimate for the mean weight. So whenever we do that, we get an answer of 71.28. So that means the estimate of the mean weight would be 71.28. That's our estimate for the mean. Okay, part B. Part B says find an estimate of the median by using linear interpolation. So we're using this linear interpolation. Okay, now what's fantastic is actually considering that first part, I'm just going to change the blue ink here. So considering the first part, we knew there was 100 players and we're going to divide that by 2. So we're going to look for the 50th value. And remember, because it's group data, it's an estimate anyway. So that's why we're going for the 50th value. So we're going to look for the 50th value. So we're going to go back up to our frequency table here, our group frequency table, and we're going to look for the 50th value. So is the 50th value in here? No, there's only 10. Another 20, that's going to be 30 so far. So is the 50th one in there? No. And then another 30, well, 30 plus 30, 60. So is the 50th one in here? It would be, the 50th value would be in this group here. Okay, so let's write down our formula for linear interpolation. So we've got the lower bound plus the number into category, over the number in category times the class width. So let's go back up to that class interval again. So the lower bound would be 68, so 68 plus the number into the category. So we're looking for the 50th value, 10, another 20 would be 30. So we need to go another 20. So we need to go 20 into that category. So 20 out of the 30. So 20 30ths of the way through that group. So 20 30ths. So the number into the group is 20. We need to go 20 into the group, and there's 30 in the group altogether, times the class width. And if we have a look at this class width, we do 72 take away 68, and 72 take away 68 would be equal to 4. So we find the class width by doing the upper bound take away the lower bound, and the upper bound would be 72, the lower bound 68, and we take them away as 4. So we're going to multiply by 4. And now we just need to type this into our calculator. 68 plus 20 30ths multiplied by 4, and that's equal to 70.666, and so on. And I'm just going to round that to 2 decimal places, so that's going to be 70.67 to 2 decimal places. And that's it. Our estimate for the median using linear interpolation is 70.67 kilograms. Okay, let's look at our next part, part C, and I've changed colour of ink to green here. So we want to now find an estimate for the interquartile range. So we're going to find an estimate for the lower quartile, an estimate for the upper quartile. We're then going to then find those estimates and take them away and find our estimate for the interquartile range. So what I'm going to do to begin with is I'm just going to write down, if we have 100 rugby players altogether, if we divide that by 4, the position of the lower quartile, or estimate for the position of the lower quartile, will be the 25th value. And for the upper quartiles, we would do 3/4 of 100, and that's equal to 75. So we're looking for the 25th value and the 75th value. So we find an estimate for both of those, then we can take them away to find the estimate for the interquartile range. Okay, so let's start off with the lower quartile. So for the lower quartile, we're looking for the 25th value. So let's go back up to the table. Is the 25th value in here? Well, there's 10 values, so no. And then another 20, that's 30 altogether. So is the 25th value in here? It would be. The 25th value would be in here. So in terms of this class interval, the lower bound is 64. So let's go down here. So for the lower quartile, the lower bound is 64 plus the number into the category. So we're looking for the 25th value. So we've gone 10 so far. We now need to go another 15. So we want to go 15 into this category. So 15 into the category to find the 25th one. Over the number in the category. Well, there's 20 in that category. So over 20 times the class width. And if we go back up the class width, well, the upper bound for that category is 68, the lower bound is 64. If we take them away, that's 4. So the class width is 4. So for our estimate for the lower quartile, we're going to do 60 plus 15 20ths times 4. This is actually quite easy because 15 20ths is 3/4, and 3/4 times 4 is 3/4 of 4, which is 3, and 64 plus that would be 67. So for the lower quartile, our estimate is 67 kilograms. So that's our estimate for the lower quartile. Okay, so we're now going to look at the upper quartile, which is the 75th value. So let's go back up to our table, and we want to find the 75th value. So here we've gone 10, and another 20 would be 30, plus another 30 would be 60, plus another 15 would be 75. So the 75th value is actually at the very end of this category. So that means that the upper quartile is actually going to be 76. You could do it using actually the formula, doing the lower bound, which is 72, plus the number into the category. Well, we need to go 15 into that category, over the 15 in that category, times the class width, which is 4. 15 over 15 is 1, so you get 72 plus 1 times 4, and then that's going to give you 76. Or just thinking about it, the upper quartile is at the very end of that category, so it's going to be 76, and that's it. So that means that our upper quartile is 76. Okay, so we've got our estimate for the upper quartile, our estimate for the lower quartile. We're now going to take them away. So 76 take away 67 is equal to 9. So our estimate for the interquartile range is 9 kilograms, and that's it. Okay, let's look at our last question, question number 5. So question number 5 is quite a detailed question. We've got a scheme has been introduced to encourage younger people to buy homes, and in Sunderland 1,200 homes were bought in 2023 under the scheme. And the table shows the ages of the home buyers. So we've got their ages, these group frequencies. So here we've got there's 145 buyers that are older than 20 but less than or equal to 25 years old, and so on. And then it says the brochures being created that will contain the average age of those home buyers. So it will contain the average age. The brochure writer wants this average to be as low as possible. So they want to give the impression that this scheme is given the lowest possible age. So they want to use the average that's going to give you the lowest result to show that the younger people are benefit from the scheme. Is that right? Should they do that? And the question says, should the brochure contain the mean or the median? So we're going to work out the mean, we're going to work out the median, and we're going to find out which one's lower, and then which one gives you the lowest ages, which one the brochure writer is going to use. Is that right? Who knows? Okay, so here we have got, let's change colour of ink here, back to our red. Here we have got our group frequency table. There's 1,200 homes, so there's 1,200 altogether if we add up the frequencies. Now we can work out the mean and the median to begin with. I'm going to work out the median because this worksheet, this booklet of questions is based on finding the median. Okay, so now what we want to do is we want to find the position of the median. Now because this is a group frequency table, we're just going to take the total frequency and divide it by 2. So we're going to take 1,200 and we're just going to divide that by 2. And 1,200 divided by 2 is equal to the 600 value. Okay, so let's find the 600 value. Is the 600 value in here? No. I'm just going to write down up to the end of that category is 145. Is the 600 value in there? Well, adding another 200 would be 345. No, the 600 one's not in there. I'm going to do this on my calculator. 345 plus 94 is equal to 439. So is the 600 value in there? No. Plus another 141. So plus 141 is equal to 580. So is the 600 one in there? No. And then we're going to get the 600 one in here if we add another 294, so add 294 gives us that's equal to 874. So the median, the 600 value, will be in this class interval here, this one here. Okay, so now what we're going to do is we're going to do the formula lower bound plus the number into the category over the number in category times the class width. Okay, so let's go back up here. So for this category here, the lower bound would be 40. The number into the category, so we're looking for the 600th value. So we're looking for the 600th value. Up to the end of the category before is 580. So we need to go another 20. So we need to go 20 into this category. So 20 over, how many's in that category? 294. So it's 20 294ths into this category here, times the class width. That's how wide that class is. So we're going to do the upper bound, take away the lower bound, the upper bound, take away the lower bound would be 5. So times by 5. And when we work this out, we'll find our estimate for the median. So let's do that. So 40 plus, and then our fraction, 20 over 294 times by 5. And when we work that out, we get an answer of 40.3401 and so on years. And that's the estimate of the median age. Okay, so we've calculated our estimate for the median. Now let's find our estimate for the mean. So we're going back up to our frequency table, and we want to remember we want to add on the column, the fx column, and we want to do the midpoint times the frequency, midpoint times the frequency, and so on. Then add up our fx column to find our estimate for the grand total, and then divide it by the number of people or the number of pieces of data, which will be 1,200. Okay, so in terms of our midpoints, we're just going to write these down: 22.5, 27.5, 32.5, 37.5, 42.5 and 47.5. I've just written down the midpoints of each of these categories, and we're going to do 22.5 times by 145, 27.5 times by 200, and so on, and then that will give us our fx column. So let's work out these values now. Okay, so we've now got those values. Let's add them up to find our total, our estimate for the grand total. And when we add those up, we get an answer of 45,085. So that's our estimate for the grand total of their ages. And then to find the estimate for the mean, we now need to divide that by the total frequency, which is 1,200. So let's do that. So we're going to do 45,085 divided by 1,200. And when we do that, we get an answer of 37.570833 and so on. So that's our estimate for the mean. Okay, so we've got our estimate for the median, which is 40.34. We've got our estimate for the mean, which is 37.57. And the brochure writer, remember, wants to use the average, which gives the lowest possible result. So that's going to be the mean. So that's going to be the mean, because the mean is obviously 37.57 as opposed to the median, which is 40.34 in terms of our estimates. So let's write that down. And that's it. I've just written down the brochure writer should use the estimated mean as it's a younger age. And that's it. And that's it. So in this video, we've looked at how to find estimates of the median and quartiles from group data. And this technique can be quite useful if you're doing questions perhaps based on histograms. And I hope you found this video useful. If you need an extra up on this topic, if you go to video number 52, there's a useful video tutorial there. And that's it. So I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.